discussed the adding and subtracting of radicals, but for a great many of you, because I didn't actually have a page of notes on it, when we came time to use it, people were like, there was not a page of notes on it, because it's exactly the same as adding and subtracting any other expressions in math class. So I didn't give you a page of notes in grade 10, but then it caused issues, so I added the page of notes in grade 11. So, just to remind you, as I said, it's exactly the same as adding and subtracting other types of expressions. 3 plus 5 is what? 8. Excellent. And of course, if we were in grade 4, I would make you show 5 different ways to show me why 3 plus 5 is 8. The only one that is really all that useful is using those little algebra thingies. 1, 2, 3, 4, 5, 6, 7, 8, done, right? Easy peasy. After you mastered addition in about grade 7, they started throwing... Well, I know, Crystal, I'm being facetious, because if I do 45 plus 72, you all still reach for your calculators. But that's okay. That's okay. So, then they brought this to the party. Variables. And everyone is like, I have a little button that says, and then the devil said, let's put the alphabet in math. And that's about when most people are like, I have no more time for math anymore. Math is numbers. Why are there letters in it? So, what is this answer? Do not say x squared. 2x. Because x is that bar, plus a second x is that bar, to get 2 bars, which is 2x, yeah? All right. Now, let's put it all together, shall we? 5x plus 3x is what? 8x. You all already know this. And yet, when we throw radicals in there, you're like, what are you talking about? Can you do this? What is that answer? No, it isn't. Can you do that? No. Why not? What makes the green expression done? And the blue expression has this third step. What? The variable. What is it about the variable? Absolutely correct. I could not have said it better myself, Crystal. You must have had a spectacularly intelligent and, might I say, good-looking math teacher in the 10th grade. So, due to the fact that this x and this y are not the same thing, you cannot tell me this answer because you do not know what x and y are. This answer, regardless, is going to be 8 of these x's. If x is 7, then that is going to be 35 plus 21, which is going to be 56, which is indeed 8 sevens, right? Okay, so let us look at why this works. This expression up here has a 5. The 5 is what we call a coefficient. And what math does a coefficient perform? It performs multiplication. So this is saying 5 x's, right? Not x times x. There will be 5 x's. X, 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 x. We are not multiplying because multiplication is the shortcut of addition, yes? And this has 3 as a coefficient. 3x, which means x, x, x. Now, you can quite plainly see I have 8 x's. Now, if it happens once in math, it always happens in math, yes? If I have a coefficient which multiplies by what we call an argument. And then I have another coefficient, but it multiplies by the same argument, then isn't that the same as 5x, 5x and 3x? Makes sense, yes? Well, if I then give you this, 5 root 3, is that not that? Is that a coefficient multiplying by an argument? So if you can work with 5x's and 3x's, can you work with all of these? Yes, you can. Because what's the 5? Coefficient or argument? Okay. What's the 7? Coefficient or argument? What has to be the same before I can do math with them? The arguments have to be the same. That's why they're both in red. So 1, 2, 3. This is the exact same thing as 5x minus 3x minus 4x plus, what would I have to write here? Y, because that is not root 7. And this answer you can do in your sleep. So this answer you can do in your sleep. What is it?
Could the grade 10 students, alpha M to Z, along with their teachers, please proceed to the rotunda for photos? Grade 10, M through Z. Thank you.
It's pretty complicated. All right. So what's the answer?
I have to go.
Of course. Pardon? Negative 6 root 7 plus 1. Plus y. That's okay. But how do you get negative 6 there? It's negative 2 root 7 plus root 2. Now, we don't like how that's written. We don't like a negative at the front. So in a perfect world, we would make that root 2 minus 2 root 7. Is that going to cost you credit in my classroom? No, not at all. Because what do I care about? The concept. Now, let's pretend somebody has some trouble with addition. Will that cost you credit?
Oh, yeah.
I kind of got to do something to you. Everybody good? All right. Now, I have said this before. I will say it again. What amount of your math knowledge is needed every single day for every single question, potentially, in this room? All of it. Up to when? Up to Friday, right? You need all of it. Actually, you need up to 10 seconds ago when I started this conversation, don't you? Okay, so look at that. Can you add those? Eventually, can you add them as they are written? No, of course not. Why? Because the argument is not the same. Now, let me ask you this. Can you add, still my highlighter, can you add that? Yeah, you can. But what do you have to do first? Some math. Some math that you learned long ago. Yes? Okay. So, you're intelligent young people. Isn't the root of 32 just some number? Okay. And isn't the root of 8 just some number? But they are not 32 and 8, are they? We would make them simpler, yes? So let us do that. How do I simplify root 32, which you learned in the 10th grade and was reminded for you on Thursday and Friday? What do I do with 32? I would do 16 times 2. Why? Because it gives me 4 root 2. What would you do with 8? 4 times 2, which gives you 2 root 2. Now, can I add them? To get what? 6 root 2. So, we take this easy knowledge that we already know, we add some new-ish knowledge, and we put it all together and synthesize how to do the more complex ones. Right? So, let us do that. Cabbages. What do I need to do there? 4 and 7. What do I need to do there? 9 and 7. And what do I need to do there? Hint, hint. 7, 7. What would be a good one to try there? 7. 7 goes into 11 once, leaves me with 4 left over. 4 and 2 is 42. 7 goes into 42 6 times. Or you get your calculator out and you do 112 divided by 7, which is what all of you did, and that's okay. So what happens here? Pardon me? 2 root 7? What about the 5? 10 root 7. And what happens here? Minus what? 9 root 7 plus what? 8 root 7. For how many root 7s? I got 10 root 7s, I'm taking away 9 root 7s, and I'm adding 8 root 7s. 9 root 7. Ya, ya? Ya, ya, ya. Anything change here? So what's that one? 4 times 5 and 9 times 5. 2 root 5 minus 9 root 5 to get what? So easy, right? Even if somehow you missed this in the 10th grade, you have all the tools you need, don't you? Do those two. Go. And of course, there they are. Is everybody good? We've done 6 of them. Is everybody cool? Now, 2A and B were slightly different because they ended up not being able to go together, yes? So just like when we have 5x plus 3y plus 2x, you put the like terms together, just like then. Where? The one that you're just on with your negative 6 plus 5. Oh, A. 7 root 2 plus 3. Yeah, thank you. I do. Thanks. Now, what's different in C? Conceptually speaking. Is there any... No, that's not concept, is it? Is there anything different, conceptually speaking, in C? No. Is there any difference mechanically speaking? Yes, because we are going to do different things with the numbers, but we are going to apply the same concepts. What is the first concept that we are going to apply? We are going to simplify. And we simplify all radicals the same way, right? We break them down into prime factors. Yeah? Now, mechanically, what will be different here? I am no longer looking for square roots. What should I be looking for? Cube roots. So, if I am good with my cube roots, do I know that this is 27 times 4? But what if I don't? What is my option here? I got to break it down old school. 2 and 27. And then I could probably stop, right? Because I trust that all my grade 11s know that 27 has a cube root. Yeah? All right. What about 32? What perfect cube is a factor of 32? 16 is not a cube. 16 is a square. 8. 8 times 4. Now, logically, ladies and gentlemen, you see 4 and 4. What's probably going to be there? 4, which means this is 64. Right? But let's say you're stuck doing the factors. Does that affect your answer in any way, or does it only affect the amount of time it takes you to get to an answer? Time. Am I any more intelligent than you that I can do that line? No. Have I had significantly more practice than you? Yes. That is the only difference. So, what is coming out of here? What's coming out? 3. What's already out there? So what do I get? 9 cube root 4. What's coming out of there? 2. What's already out there? What's that? Negative 4 cube root 4. And what's coming out there? And what's already out there? So it is cube root 4. Now, do I have coefficient, argument, coefficient, argument, coefficient, argument? And are all those arguments the same? Even though they look different than the square roots, they are still the same argument. Just like a y looks different than an x, but we follow the same concept. So, what's my answer? 17 cube root 4. Now, a bunch of you are going to make the simple mistake. You're going to forget because you're so used to seeing this symbol and 4 as being 2. You're going to do that. You're going to tell me that that equals 2. Please don't. Right? Because that's a different, that's messing up the concept. Right? That shows me that you're just memorizing steps. Everybody cool? All right. What is happening in D? Because D...
Could the grade 9 students, A through L, please proceed with their teachers down to the rotunda for photos? Grade 9s, A through L. Thank you.
Why does D scare you? Why does D feel like you're watching Paranormal, whatever that movie was called? I don't remember. Because I didn't see it because it looked like a piece of garbage. But I've since found out, I don't know if you guys know this. You probably do because you're all over the internet. Did you know that the guys who made that movie added sound to that movie that you could not hear? There was sound in that movie that was of such a low frequency that you could not hear it, but your body could feel it. So when you saw that movie, you felt, ugh, but you didn't actually hear or see anything to make you go, ugh, but your body went, ugh. Crazy, hey? I just learned that. No. Because now I know the trick. Crazy though, hey? Now lots of movies have done crap like that in the past. Right? 4D, you've all seen a 4D movie at Disneyland. When you see Bug's Life and the chair stings you in the ass. right? I know, it's the worst. You're sitting there and, oh my God! And when you're on flying over California in the orange mist, and they're like, oh, I'm flying through an orange thing. No, you're not. You're sitting on a chair 5 feet off the ground. You're not flying through nothing. But your brain is like, oh my God, I'm flying, woo! Right? And your tummy goes, woo! And even though you've only moved this far, yeah? All right, so we all know that. The Harry Potter ride at Universal, when the dragon blows on you, and it actually is like, oh my God, it's so hot. And if your eyes are open, they actually dry out, right? Like, you've all been there. Same thing. The Transformer ride, yeah. All right, so we're all cool? So that was my little new piece of knowledge for you if you didn't know that. Paranormal activity messes with your body, not just your brain. Okay, so what? Bring it all back, tie it all together in a neat little knot. What here is the sound that you can't hear that makes you go, fractions. But of course, we know how to deal with fractions, don't we? Right? I don't remember how to deal with fractions, Mr. Myers. I have no idea what I'm doing right here. But you do, because you are going to bring all your math to the party. Let's pretend you have no idea how to approach this, but you do see that, and that. What is something you could do right now? You could simplify them. Never look at a question and say, I don't have any idea what is going on here. Because one, that insults me. Would I ever give you a question that you cannot do? What would be the point of that? To make me feel smarter than you? Big deal. You guys could give me a question that I couldn't do either. You couldn't do it either, but who cares? Right? You could do it. You could all Google some really hard math question. You give it to me, because I haven't actually taken high-level math since 1992. Right? Since before some of your parents were born. It's possible, biologically speaking. 1992 was 30 years ago. Yes, it's possible. I just said it's possible. Why what? Because I'm saying that's how long it's been since I've done some high-level math, so you could all come up with something that could stump me. And why would you do that? It would be to make me feel, it would make... But it's obviously before you were alive. All right. So what are we going to do here? What am I going to do with 48? I got 8 times 6, yeah? Right? And for 162... 27 times 6. And for 750? 125 times 6. So let's tidy this up. What's coming out there? 2. So I got 18 cube root 6 over 2, right? What's coming out here? 3. So that's 9, right? 9/4 cube root 6. And what's coming out here? 15 cube root 6 over 5, right? Everyone agrees? Looks exactly the same, except we've done the simplifying, yeah? Now again, Mr. Myers, I got no idea what to do, but you do have an idea of what to do. What do you see right there and right there? What can you do? I can simplify. What's 18 divided by 2? 9 cube root 6. Cool in the gang. Plus 9 over 4 cube root 6. Minus, what's this? 3 cube root 6. Wow. What do you see there and there? Isn't that what we've already been doing? I got 9 cube root 6, and I'm taking away 3 cube root 6s. What's that? So now I got 9/4 cube root 6 plus 6 cube root 6, yeah? Right? Okay. Well, Isn't 9/4 2 1/4? Isn't it? Well, okay. So what's 2 1/4 plus 6? 8 1/4 cube root 6, yes? Now what would you do? What do you do when you see that? What do you do? A radical. It's already a radical. I know what you're trying to say. What did you do in grade 3 if you saw that? You did 33 over 4 cube root 6, right? Is this right? Is this right? Are we done? Is there another way we could have done it? Is there another way I can write that expression? How could I write that yellow thing in another way? Nine cube root 6 over what? 4, right? And how could I write this in another way? I could write 6 cube root 6 over 1, right? And then what would I need? What would I need to add 9/4 plus 6 over 1? Same denominator. So this would have to be 4, and what would this become? 24. Isn't 9 plus 24 33? Now, even though this big thing made all of you paranormal activity yourselves, was there any reason for it? No. Because you all knew something to do. What is the number one instruction that I've been giving most of you for at least 2 years? Starts with an S, ends with a Y, has implif in the middle of it. Simplify. What is the root word of simplify? Simple. Make it simple. There is no need to be scared of anything in math class because you all know how to do every question I give you. All right, let's have a look at 39. I want the perimeter as a mixed radical. So how do I find the perimeter of a triangle? You add up the sides. Do I have the measurement for the sides here? So what do I need to do? Add them up. 5 root 28 plus 3 root 252 plus 5 root 112. Can I add those? Not yet. What do I got to do? Simplify. What's this guy? 4 and 7. What's this guy? You're guessing it's 7, right? Okay, because you knew this was the not perfect square there. So I'm going to use 7 there. How many 7s going to 25? 3. Leaving me with 4 left over. How many 7s going to 42? 6. So it's 36. And what's this one? We already know. We just did it. 16 times 7. Right? Again, some of you are hearing your peers muttering the right answer way before you have it, aren't you? Are they smarter? I disagree. They happen to be a little more proficient in multiplying. There is a difference. right? Could I, with the internet, change the brakes in your car? It would take me forever. I'd screw up a bunch. I'd bash my knuckles. I'd say a lot of colorful swear words. I'd probably cry, but your brakes would be changed. If you took them to Mr. Wimmer, would they be changed? Would they be changed faster? Is Mr. Wimmer smarter than me? He's more proficient. There's a significant difference, yes? All right, so this is 10 root 7 plus 18 root 7 plus 20 root 7, which is 48 root 7. Yeah? Ease, bees, lemon, squeezy, right? Okay. Find the perimeter as an entire radical. If there's 148 out there, how many 48s are under there? 2. So it'd be the root of 7 times 48 squared. What do we know about that number? It's going to be colossally large. Do I care about it? Or is this the part that I care about? That's what I want to see. Let's say you don't have your calculator that day. Do I really care if you prove to me that you can do 48 times 48, get a number, and then multiply that answer by 7? Do I need you to show me grade 5 multiplication? No, of course not. But if you have your calculator, that's super easy, right?
Could the grade 9, alpha L through Z, please come down, and all staff and EAs, please come as well. That's all staff and EAs, grade 9, L through Z. Thank you.
I wore my same tie like I have been for 7 years. Oh, only 7 that have had the same tie and shirt. So that is the square root of 16,128. Now, ladies and gentlemen, we haven't talked about this yet. That's the next thing we're going to talk about. But as always, I end a lesson with the lead into the next lesson, yes? So, I want you to find the half perimeter. Blue or green? Which one is easier to work with? Or sorry, blue or yellow? Green. Yeah, green's easy to work with. I never highlighted it. That's real easy to work with the green one. There's nothing there. Ha ha, done. But seriously, what is easier to work with, blue or yellow? Why? You wouldn't want to divide what, Crystal? What she said. Yes. Blue or yellow? Because we are trying to find the half perimeter. These are the two perimeters. Sorry, Preston, that's on me. Of course. The half perimeter is the perimeter that we have divided by 2, yes? How do I write that? It would be perimeter, whatever it is, halved, right? Obviously, 48 root 7 cut in half is the easier one to work with. Now, you may say to yourself, that we haven't done any division with those, but we have 1,000,000 times, because this is the exact same thing as 48x over 2. What would be this answer? 24x. So what is this answer? 24 root 7. Yeah? Yeah. Now, we had this formula. We have used this in the 10th grade. I can't remember if we used it this year. Yeah, we did. Yeah, it was that one question that everybody left blank, yeah? Oh, not in this class, right. So, S is the semi-perimeter. Half perimeter. What is S? Right there, 24 root 7. So I'm going to have the square root of what's S? 24, dummy head, 24 root 7 times S minus A. Well, that's 24 root 7 minus what? One of the sides. Which side?
Let's do 10 root 7.
Doesn't matter, does it? We've already got it in root 7s, don't we? So, 24 root 7 minus 10 root 7 times what? 24 root 7 minus 18 root 7 times what? (20 root 7s). Yes? Now let's do math. It looks big and scary, but it's not, is it? 24 root 7 times, what's this one? 14 root 7. Agreed? What's this one? Agreed? What's this one? Agreed? Now, if I were to tell you no calculator now, how many of you would get the paranormal activity? Ugh. Be honest. Be honest. But do we need to? Do we need to have that feeling? Of course not. Because isn't this the square root of 24 times 14 times 6 times 4? And the square root of root 7 to the 4th power? Isn't it? Okay. How do I simplify 24? If I only had this, what would you do with that? What would you do with just the 24? I would use 6 and 4. Normally, we might do something else. But in this case, 6 and 4, because what does that give me right there and there? Isn't that a pair? And what does that give me there and there? So what's coming out here? 6 times 4. Now they're gone. And they're gone. What's this? Does it get any simpler? It's 2 times 7. Any pairs? No. So 14 staying under there. How many root 7s can I get out? 2, right? Everyone agrees? So I'm also going to get out here a root 7 squared, yes? Well, what is root 7 squared? It's 7, isn't it? Why? Because root 7 times root 7 must be 7. Why? Because that's 7 to the 1/2 times 7 to the 1/2, isn't it? What do I do with the exponents? Add them to get 7 to the 1. 7, 7, 7. Agreed? So I got a 7 out here now, yes? What's 7 times 6 times 4? What's 7 times 6? 42. What's 42 times 4? 160. What's 2 times 4? 8. So 168 root 14 with no calculator at all.
Could you, like, take a couple steps back to do, like, 24 times 14 times 6 times 4 to the root of 7, and then, like, unwrap that big number?
So what you're saying is Preston is asking right here, could I not have done this? Root 24 times 14 times 6 times 4 times 7, right? Because root 7 to the 4th, but it's not going to be 7, is it? Root 7 to the 4th would be 49, right? And then do this. Now, most of you are going to say, oh, damn, times. You're going to get a giant number, then you're going to break that number down. But you don't need to, because it's already broken down, isn't it? Right? 4, 6, 7, 2, 4, 6, and 7, 7. There's a group of 2. There's a group of 2. There's a group of 2, leaving 7 and 2. 14 under there, and 4, 6, 7 outside. Right? Everybody cool? This, scary. This, grade 10. So really, what's difficult here? It's only the looks that are scary, yes? Is the math? No. You are going to do page 40 for homework. Go.